Okay, so welcome back. So we were looking at how we can go about as a professional for sustainable design of any product, processes, and other stuff. So let's look at some of these. We'll start with where we ended in the previous module. So let's look at some of these useful tools and incentive. So in terms of the tools and incentive, say from a federal government, from a government standpoint, so research, government funding and incentive program, so that people can start thinking about sustainable design. These are many times these type of say it's early science. People are still going into this field, so we need to develop a lot of data. For example, we were talking about LCA in the first up to fourth and fifth week. We went about discussing about life cycle analysis in a great detail, looked at some of the examples, and during next week module, which is the week 8 module, we'll again go back and do a lot of case studies of life cycle analysis from different like spheres. But like when we do this life cycle analysis, as you saw, for this inventory analysis we need data. Now this data has to come from somewhere. If we keep on using data from, say, Western European country and do the LCA in India, that's actually not really true. I would say that's true representation of what is like. We need India specific data, and there are some data which has been developed. There are some data developed in different universities. There are some organizations in India who are trying to bring the data together. EcoInvent, which is a global organization, is also trying to develop some Indian based database, which we like my research group is also part of that. But all these when we do this data collection, that's not really pure research, because in research people say it's more like a consulting job rather than a research job. But unfortunately, this consulting jobs nobody pays. So because it's that no industry is interested in collecting this kind of database, because this kind of database is needed so that we can do that environmental footprint calculation. And unless the government comes up with the regulation where all the products and processes and everything has to be done LCA, and then even in that case people will say, okay, we'll just use whatever the data is available. But I think the money for this kind of activity, although it may not be 100% pure research, but the money has to come from government agencies, because that's where but otherwise who will pay for it? I don't see any other funding mechanism for these things to happen. Similarly, if we are trying to develop we want to have a housing for all. So housing for all requires a lot of raw material. So that means better resource management. So for better resource management, one of the aspect is, let's take some of this waste material and try to recycle and see whether we can use it as a construction material. Now we are trying to use it as a construction material. We have to be sure that, of course, it's good structural wise. That's, as a civil engineer, we all know that. Those of you who are not civil engineer, you also know that if you want to use any material, it has to meet the structural property for what it is intended for. And then you also have to make sure that this material, since it is coming from waste sources, it's clean enough. So we have to do what is known as the beneficial reuse risk assessment. So this beneficial reuse risk assessment, this structural aspect, and these days we are talking about this life cycle concept. So all these three needs to, if we can build up all these three together and come up with a nice framework, which any waste industry or any manufacturers can look at and say, okay, if I will go through this step, which is a structural aspect, environmental aspect, and also I'll see how much environmental footprint I'm reducing, and then I'll go and use this material for my construction purposes. So that's these kind of tool needs to be developed for India specific tool, and that again, the funding for these kind of things has to come from government agencies, and nobody else is going to pay for it. So we don't have any other funding mechanism to pay in this particular country. So that's so the research funding has to be there. Research government funding has to be there for those kind of stuff. Same thing for the industry part also. There should be some incentive program. So even tax program or other programs has to be there. There could be utility incentive programs where you get some tax breaks, so you get some other stuff. For example, there is a green building program. We have that Griha program. We also have LEED certification. That Energy Star system. So all these different programs, there should be some incentive built in. So there are, in some places we do already have it. but we need to kind of elaborate on that more, and we need to incorporate many make it more practical, make it more which works better. So we need to have so like if you look at some of the other programs which is going on around the world, one of the program is this LEAD program, which is the Leadership in Energy and Environmental Design Credit System. So that's a Leadership in Energy and Environment Design Credit System. Many times you hear this is the LEED certified building, so that's what it is. So that's it's a leadership in energy. So they have gone through a certain process, certain evaluation, certain protocols, and then if you meet those, if you pass that particular process, you become a LEED certified building. So the LEED, which is what is their mission for LEED, and it's the mission is having promote and accelerate adaptation of green awareness. So we have to make it more and more green awareness. So what do you mean by green awareness? To become more environmental friendly. So and how we'll do that? We will try to create better buildings and communities, healthy places to live, work, and play. So it's healthy places to live, work, and play means indoor. We should have much less air pollution issues. We should have good ventilation. We should not use any chemicals which will leach off, so that I'm inhaling all these nasty chemicals while I'm taking a nap in my house. So those things should not happen. So that's should be, it's a healthy place. It's an enjoyable place. So that's what the LEED's mission is. So there are different levels of LEED certification depending on. So there is a total 70 points you can have a score, and if you are you can go and look at more details on LEED certification on this. They have a website for LEED certification. So the basic stuff is around 26 to 32 points. So you have to score slightly less than half to have the basic, and then silver, gold, and platinum, that certification is there. So as you can see, it's not it seems to be very competitive certification. It's not that easy to get that, because even for platinum the score is only 52, which is around less than 80%. So 75%. So it's what is needed to get the platinum certified. So it requires a lot of stuff. So credits are divided into 6 categories in terms of sustainable sites, like how good is the site in terms of its environmental and other environmentalist aspect. Water efficiency, how good is the water usage, how they are doing in terms of the energy and the atmosphere. The material use, material and resources, material is part of the resources, indoor environmental qualities, innovation, design process. So all these different categories, they are divided, and for each category based on how they perform. So there is a standard template. There are some standard questionnaire, a standard template, a standard forms that needs to be filled in. So and that's the same set of forms is used throughout the world, so that you have you have a uniformity in terms of which buildings are LEED certified. So based on these parameters, they go about the certification. So in terms of different point wise, what is the breakup? Innovation and design, that gets around 5 points. Sustainable sites, that's one of the important one. It's around 14 points. Indoor environmental quality, 15 points, which around 22%. Water efficiency is 5%. Energy and atmosphere is 25%, and material and resources 19%. So this is how the different aspects has been divided for the LEED mission, and this based on what they have come up in terms of the distribution. So that's how it has been done. So that's in terms of the LEED mission. So what is the benefits of LEED project? They use less energy and water. So it's less energy and water, less energy footprint, less water footprint. So that's always better. Use of the material wisely. So not too much of an over design, which is again we tend to do that. We tend to do too much of an over design of our structures and other stuff. That since you have to use material wisely, you try to less over design it, and you try to minimize the waste. And if you try to recycle the waste within the system as well. Have longer economic life, try to use the material which will last for a long time, cost less to operate. That's another areas where we can try to improve upon. Generate less greenhouse gas, pollutants are more comfortable, occupants are healthier and more productive. So these are what is the kind of the focus in terms of the LEED mission. So this is what we are trying to achieve. So So what and then in terms of what they require architects, mechanical engineers, civil engineers, electrical engineers, structural engineers, transportation, site servicing engineers, stormwater management engineers. So all these people are required in a LEED project. So as I was saying to you earlier as well, we as a engineering projects, within the engineering, when we are studying an engineering program, we work too much into silos. Like we get into silos. When I say silos, we get compartmentalized, which is say you have a civil engineering people here, mechanical is there, electrical is there, and they are not talking to each other. But when they come up the real world project, as you can see in this particular slide, we need all sorts of people to work on one particular project. Just think about the room you are sitting in right now. If you just see around, there will be light, there will be electrical wiring, there will be, if you are an AC, there is an AC there, there could be, as you walk into the washroom, there is a water connection, in the kitchen you have a water connection. So you need lots of different kinds of people to help you build as simple as like a very simple building. So think about the big complicated commercial places or industrial places where all the different aspects of engineering is required. And there is always a myth, we call it that green cost more, that there is a more cost to the green whatever we do in terms of green products, they cost more, which is not really true, because it's as you can see over here that in terms of academic buildings, which is tells you the cost per square feet. And the gold certified is your golden color, the yellow color. Silver is gray. Green is your just the certification, and the other gray, that light gray. Actually, the silver one is the blue, which is the dark gray showing up on the figure, and the light gray is not certified. So as you can see from top to bottom, the cost per square feet, it kind of varies. Even for the buildings which are not certified, we are seeing pretty high cost. And while the buildings which are certified, you see the gold color ones are actually low cost. So it's a low cost than many silver or many like certified buildings too. So to have that having the green, anything green will cost more, that's not really true. And this graph came from a study which was almost 10 years old. So now the technology has improved so much. So if somebody does a similar study today, you will my guess is that you will find even less cost so for something which is like a green certified or LEED certified. So it's not that anything you go for green is always cost more. It actually costs much less if you look at the long term cost as well. So this is again for the earlier was for the academic building, and this is for the library, and here again you see the same thing. It's the cost of many of the cost which is not certified is more than what is certified buildings. So and then the thing is that we have to have we have to document the steps for staying on track. For any project, we have to document as early as possible and maintain it. Monitor sustainability checklist, have a clear picture of what is our goal in terms of sustainable goals. Energy, and do the energy model, do the cost model, use it as a design tool to minimize the energy requirement, minimize the cost. And those things, if you do properly, you don't end up paying more by going for a green building. Actually, as you saw from the previous two slides, actually for many cases having a green building or a LEED certified building is actually less costly than having the traditional building. So then the budget, how much more, like budget pointer should not be how much more it will cost, but we should rather focus on how will we do this. So you ask early in the project, and you consider in every part of design, establish the team goal. Of course, it's all a teamwork. Establish team goal, deal in you should always not decentralize. You should not, that's another problem we have, especially in developing countries. We are too much power hungry people. We always try to concentrate power in one place. We don't want to delegate. and which is and that makes a lot of suffering to everyone. So the person who doesn't want to delegate is also suffering because he is working too much, he has to work too hard, and he has to spend too many hours. And any human being, after he or she has been working for 8-9 hours in a day, their efficiency goes down. So if somebody comes to you and tells you that I work 12 hours, 14 hours per day, great, you might be working, but actually you are not working very efficiently after 8 or 10 hours. Nobody has that capacity unless somebody is a superhuman. There has been studies done of several studies done in this area where they have found that optimum, that's why the working hour is 8 hours. The reason to keep 8 hours workday is that people can work efficiently for 8 hours. After that, their brain does not really work very well. So some people can stretch it to 10, maybe 12, or not more than that. If somebody claims that they do more than that, they are just I would say faking it. They are not really working over there. Or but we should establish the team goal. We should have the expectation of the different people in there. What is really the expectation? What is the expectation of each and every team member, and what expertise who will contribute? What is the specific goal in the program? What is our specific goal? Align budget with the program. What is the budget? Stay on track for design and construction, especially for any project we are talking about. So all these, most of the time, once the project gets delayed, there is a cost escalation. So we have to always, if the project is on time, it's always you may end up actually spending less money than what you thought for that particular project. So so we should always focus on trying to be on track, and be very clear. Having a delegation delegate the responsibilities, delegate the powers, have very transparent system of management. And that's not only true for even for this, that's true for any management, whether you talk about any sorts of management happening anywhere in the world. But that's at the same time, it's also relevant for when you're talking about this green building and other stuff. So, but it takes a collaborative effort. It cannot be done by a person or two person. It needs a collaborative effort. So owners, planners, designers, builders, educators, decision makers, regulators, all should find means to work together and towards a common goal. Because if we are doing this, everybody is going to benefit from that. So it's not one person's baby. It's every people who are involved in this project is going to benefit, or the whole society is going to benefit actually, because if we can save money, if we can do things better, if we can make things greener, it's always good for the whole thing. So in terms of the summary of that, the world will not evolve past its current state of crisis. That's what I was trying to say earlier. So in terms of the sustainable development, the world will not evolve past its current state of crisis by using the same thinking that created that situation. So that's what Albert Einstein said. So we have to start thinking differently, and that's true for most of the scenarios. So what you can apply immediately, any project you are working on, that depends on any project that you are involved in, develop a sustainability checklist on project. You make a sustainability checklist. Then you recommend sustainable solutions to clients. Adhere to sustainability principle in your work. Use sustainability resources. So there are lots of resources out there. Use them. And that resources will help you to make progress in your project in terms of different aspects of the project. So we need to think about that. That if not this way, then how? If not now, then when? If not us, then who will do it? So that many times we get that, okay, let's do this project in the old way, and then from the next project we'll think and do it in a more sustainable way. Next project never comes. So and every time we do the same thing. So we need to start thinking about, if not now, then when? We have to manage this in a proper way. If we cannot do it, if we don't want to do it, who else will do it? Like if we don't want to do it, I have no right to expect others to do it too. So and if we not go the sustainable way, then how we'll make progress? How the sustainable development goals will be achieved? So how we can come with solutions of different world problem. So in terms of the engineer, we play a very important role in the global sustainable development by designing product systems and like using materials, chemicals, and all those kind of stuff, they have an impact on environment, economy, and society at different like time interval, spatial scale. They are also spatial as well as temporal scale. So that's that vary from local to global or from minutes to decade. As engineer, we create design and then not only evaluate the design but also embed the design into the complex system. So that's what we are trying to do. So let's look at an example from the transport sector for what we have been talking so far. We have been talking about the sustainable engineering and all that. So what from the transportation sector, how things are working right now. So, and this is an illustration for like what has happened in last few decades. So field of transportation provides an illustration of multiple layer of system with engineer creates and design. Among the most visible project is automobile. You see cars, like you go to any nowadays, even in the rural area, semi-urban area, you see some cars. In the urban, if you go to big cities, lots of cars. So we see cars, and then these cars are made by unfortunately the engineers. They are, if you're too much worried about, if you're too much I'm just joking here, but if you are stuck in a big traffic, you can blame the engineers. So that's if they have not created this car, we would not have the traffic. But that was a joke. So that was a joke. So among the most visible product which is designed by engineers are automobiles, the cars. So engineer they design car. When we say design car, means they design different parts of the car parts which get assembled together. So we design engine, we improve. So we can improve the engine. Remember, we have this in Indian context. You see this Euro 1, Euro 2, Euro 3. What are those Euro 1, Euro 2, Euro 3? So again, you should always think, as I said in a previous module, always have a habit of asking that question why, and also try to think. Don't let your brain become idle. You should always ask that question. What is Euro 2? What is Euro 3? Or if there is I'm not sure whether Euro 3 exists, but whatever is that Euro that you have, why they are there? What are those requirements, and why we should meet that requirement? So those requirements are needed because of we have this fossil fuel powered engine which creates a lot of air pollutants. So to increase their fuel efficiency and reduce the environmental impact of the emissions associated with the burning fuel, which we want to become it more fuel efficient. So if you make it more fuel efficient, what does it mean? You are reducing the operation and maintenance cost, because if the cost of fuel is less, if you're making it fuel efficient, so that means to go from point A to point B now, it will use less fuel. So if it uses less fuel, that means I have to buy less gasoline or less fuel to put it in my car, and that saves me some money to go into my pocket. So that's kind of helps in terms of the cost, like reduction in the cost. So in terms of size, power, and the fuel efficiency of the engine, they must be handled with the weight of the vehicle. So however, if you change the engine, if you make the engine lighter, so that will help reducing the weight of the vehicle. That again helps it further. So then it helps if the engine gets better, we have the reduction in emissions and operating cost. So if that goes down, we can possibly lower the cost of the vehicle as well. So those can be achieved. Use of materials also and fuel by automobile. In terms of their fuel and material supply systems is there. We can develop a system to recycle the material at the end of its life. There is even many countries they do that. That at the end of when the car is totally cannot be used anymore, so they use it. They take it different parts apart and try to recycle as much as they possible, and part of it also goes to waste to energy plant. Use of alternative power source, rather than using the gasoline, can we use electric car, which is already there. We can use biofuel, which is being used, and if they are used, how they impact in terms of the global flow of fuel, and what is in terms of their environmental footprint. And if we can design the cities that reduce the need for personal transportation, if we can come up with public transport, if we can come up with a very nice public transport, then people will not go for personal transportation. So if you go to many cities around the world where the public transport is so good that people avoid driving their own car, because the parking becomes a problem. Parking charges are pretty high, and they have been made in such a way so that people are people are kind of encouraged to use public distribution, public transport system rather than private transport. So if you look at this particular sketch, this is what we are talking about. Here you have your automobile subsystem where engine and paint, those things are there. That goes into making the automobile, where automobile is manufactured, used, recycled. That kind of goes into the infrastructure technology based on how the automobile will behave. We have to design our highways, we have to design our petroleum industries. So that's your infrastructure technology, and based on how this whole thing behaves, that kind of goes into the social structure where dispersed communities and businesses and malls. So as you can see here, that engineering design for they are variety of system scale is here. So we can go from just from the automobile part to the automobile, to infrastructure, to even the social structure. So you can go at different level, and so that's and within we can look at the system as well as gate to gate, like we can have a subsystem, we can have a cradle to grave, the automobile system, or the inter-industry infrastructure and extra industry societal system. That will be the whole thing. So as you can see the different circles in this particular image over there, each circle can represent a system boundary for doing an LCA exercise. So and that will be at different levels of LCA exercise to do that. So that would something which is important, will be important to do. So the point of this example is to illustrate that sustainable design of engineered system will lead to multiple spatial and temporal scale, and that requires a lot of interaction with professionals within many different backgrounds within and outside of engineering. So it's not only an engineering solution, engineering problem and engineering solution. So any problem, even the transportation industry problem is transportation engineering issues, many requires a lot of input from non-transportation engineers, because that's how you saw that societal, how the people will take the public transport, whether people will go for that. So all those things comes in picture. Sustainable design challenge, they get complex, and then we need to have tools. There are some tools which is emerging. LCA is one of the tools, but there are other tools which are emerging to make. So in this module, the goal was to introduce the tool that are currently available, which is a combination of both principal and quantitative analysis method. Next, because the sustainable design must be able to compete in the marketplace, so you need to have a quantitative method so that you can monetize, because you have to look at the monetary point of view, how to make it competitive. Then environmental factors that needs to be discussed. Then non-monetized environmental indicators, for that how you may not put a money value for it, but you have the environmental footprint. Indicators of social impact for engineering. So those things are needs to be incorporated. These are the social aspect, as I said earlier, it's in initial stage of development, but it's still they are trying to come up. We have a social LCA kind of methodology already in place, which is developed by UNEP and CTAC. So that can be looked into there as well. So let's we'll stop in this particular module over there, where again we have what we have looked at in this particular module. We have tried to see in terms of we looked at this transportation industry example, and we try to see that how we can achieve and some of the basics before that. And the overall goal is we have to make something, we have to design product processes to be more sustainable. And the LCA part kind of tells you that how to evaluate sustainability, but then there are other aspects. Here we are start looking at the economic aspect, and which LCA doesn't do it, and also the social aspect. So the social and economic aspect also needs to be considered in terms of better product design or process design. So with that, we will have a closure of this particular module, and then in the next module we'll start looking at some of these sustainable engineering principles, some of the document which has been prepared. So we'll review some of those documents, like a brief summary, and that would be in the next module. So okay, so thank you very much again. I hope you are enjoying the course, and I look forward to seeing you again in the next module. Thank you.